This chart shows a trading desk generating steady profits, right up until the moment it collapses. When a financial institution relies on an algorithm that gets the math wrong, a single exposed anomaly can erase billions in capital. As quantitative researcher Ratanlal Mahanta puts it, model risk is hidden risk. Mahanta spent his early career, from roughly 2011 to 2018, deep in the plumbing of the markets. He built the low-latency infrastructure and quantitative strategies that connected servers directly to co-location centers, like the National Stock Exchange. In those days, the job of a quant often followed a straightforward path. You find a mathematical formula to price a financial derivative, and you use it to execute trades and manage your baseline market risk. But building a strategy to generate yield is only half the job. As markets absorb complex data at higher speeds, the real challenge for a quant is actively trying to break those pricing models to ensure they can survive the chaos of the real world. To catch those hidden vulnerabilities at an institutional scale, the approach to validation had to evolve. Between 2019 and 2022, Mahanta focused on building out reusable, automated Python platforms that systematically interrogate trading models. Instead of manual spreadsheet checks, the automated script actively ingests the trading logic and fires thousands of simulated data points at it, aggressively testing the statistical assumptions holding the model together. The system then runs heavy Monte Carlo edge case simulations to locate exactly where the math breaks down. The final output is structured directly into formal, audit-ready reports. This automation shifts the quant's focus, moving them from a builder of tools to an impartial mathematical auditor who ensures reproducible safety across the institution. These automated audits exist for a very specific reason. International regulators demand rigorous proof that banks hold enough capital to survive massive market shocks, codifying these rules in frameworks like Basel III. This visualization breaks these rules down into specific stress tests. One framework, FRTB, measures the damage if the broader stock market crashes. Another, IRRBB, tests what happens if global interest rates suddenly spike. Then you have a third crucial framework, CVA, or counterparty credit risk. This specifically measures the danger of a trading partner defaulting before they pay you what they owe. Let's test this intuition. If a bank sells a fuel price derivative to an airline, and that airline suddenly declares bankruptcy before settling the contract, which of these three stress tests accounts for that specific danger? It's CVA. The modern quant's job is to build the math that proves to regulators the bank has enough capital reserved to absorb that exact default without collapsing. Predicting that airline bankruptcy used to rely strictly on rigid formulas, like the Merton distance to default model. But in his 2024 and 2025 research, Mahanta replaces those traditional formulas with large language models. By training machine learning networks to read, models can now instantly digest unstructured alternative data, like live news articles, public sentiment, and earnings call transcripts. The network synthesizes that qualitative data and translates it into a highly precise curve showing a specific corporation's probability of default. AI functioned here as a high-throughput engine, converting the chaos of real-world events into highly accurate risk metrics that math alone might miss. Looking toward the research frontier in 2026, these tools are evolving into agentic AI systems. We are moving toward unified environments where autonomous agents continuously monitor global markets, stress test portfolios, and update credit models entirely without human prompting. This infographic maps the complete modern quantitative pipeline. You start by building the stochastic math to price the asset. You automate the validation using Python. You run the regulatory FRTB and CVA stress tests to secure the capital. And finally, you hand the operational loop over to Agentic AI. No matter how sophisticated these autonomous networks become, their safety always comes back to step 2. The entire financial ecosystem is only as stable as the rigorous mathematical validation of its hidden risks.